the solution to QR code 3. So in this question, you're told that you've got a plane travelling 125 kilometres from point A point A, plane travelling 125 kilometres on a bearing of 30 degrees. So if we've got a bearing, we need to remember to draw on our north line. We don't actually need to know where north is. We're always going to take it straight up from A. And we're told that that bearing is 30 degrees. So that's measured clockwise from north to 30 degrees. So that's the 30 degrees there. And we're told that that's 125 kilometres to B. So that's 125 kilometres there. We're then told that the plane flies from B to C on a bearing of 160 degrees. Now again, your north line is going to go up, perpendicular from B, and your angle is going to be 160 degrees. That's not quite 180, so C is going to be over here somewhere, and that angle is in here, 160. This doesn't have to be accurate, you don't need to measure it, it just needs to be a rough drawing. And you've got C here, and that is 184 kilometres away from B. We're then asked to calculate the direct distance from C back to A. So we want to find this length here. We're going to call that X. Now, we've got a non-right angle triangle. It's a calculated paper. We need to decide how we're going to work out some of the angles in this triangle to help, either to use sine rule or cosine rule. So what I do know is at B, I could continue straight line down like that, that would be south. And I know that from north to south is 180 degrees, so that tells me that this angle here is 20 degrees. I also know that north will always be parallel to north, so that gives me a parallel line and a parallel line and a Z angle, so that tells me that this is 30 degrees. So this angle here in total, if I add those up, is 50 degrees. So I know that that angle is 50 degrees. And even better, that angle is now sandwiched between this length and this length. So that means that I can use cosine rule because the angle is in between the two sides that we've been given. So I can go straight to the front of the formula booklet and find my a squared equals b squared plus c squared minus 2bc cos A. And cos A is the angle opposite the side we're trying to find. A is the side we're trying to find, and B and C are the sides either side of the angle that we've been given. So I then know that a squared, which I'm now going to call x because that's what I labelled it in my diagram, x squared is equal to 125 squared plus 184 squared minus 2 lots of 125 times 184 times cos 50, because that's the size of my angle between the two sides I've been given. I can use my calculator. Now, my own personal preference here is to actually do the single calculation because it means that you are less likely to make a calculator error, entry error. So 125 squared is 15,625. 184 squared is 33,856. And then the bit in the bracket works out to be 14,784.5. 11,502. And I would keep all my decimal places at this point. I'm not going to work this out. I could now do that calculation here on my calculator. I'll trust myself to enter that. And that gives me 34,696.88498. And to find the final part, because I've got x squared here, I need to square root everything. So that's going to give me 186.27 rounded kilometers. Or if I want to put it to 3 significant figures, I could just write 186 kilometers, 3 significant figures. Because in the question, the numbers were given to 3 significant figures in the first place, so I could do that.